Please watch my videos and like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from the section Complex Analysis and it is related to entire functions. This question is from the part B, which is a multiple choice question and it carries 3 marks. Its question ID is 704034. This question is suitable for all these examinations. Right. The given question is, let f be an entire function that satisfies mod fz less than or equal to e power y for all z is equal to x plus iy belongs to set of complex numbers where x, y are real numbers. Which of the following statements is true? We are given 4 options. Option 1, f of z is equal to c e power minus I z for some c belongs to a set of complex numbers with mod c less than or equal to 1. Option 2, f of z is equal to c e power I z for some c belongs to the set of complex numbers with mod c less than or equal to 1. Option 3, f of z is equal to e to the power of minus c I z for some c belongs to set of complex numbers with mod c less than or equal to 1. Option 4, f of z is equal to e to the power of c I z for some c belongs to the set of complex numbers with mod c less than or equal to 1. For all these functions given in options 1, 2, 3, 4, we will check whether it has the given property, namely mod of fz less than or equal to e power y for all z is equal to x plus iy belongs to c where xy belongs to r. We do it in the next slides. Right. We now discuss the solution of the problem in detail. We have an entire function f which satisfies this condition mod fz less than or equal to e power y for all z is equal to x plus iy belongs to c where x and y are real numbers. We will now check which of the entire functions given in the options 1, 2, 4 has this property. Let's call on option 1, f of z is equal to c e power minus I z is an entire function, obviously. For some c belongs to set of complex numbers with mod c less than or equal to 1. We will check this function has this given property. Now mod of fz is equal to mod of c e power minus I z is equal to mod c, mod of the product is equal to product of their mods, mod c into mod of e to the power of minus I into, for z we have written x plus iy. And mod c is given to be less than or equal to 1 is less than or equal to e to the power of minus I into x minus ix minus I into iy is plus y. So it is less than or equal to e to the power of minus ix plus y, and this is equal to mod of e to the power of minus ix multiplied by mod of e to the power of y. Mod of e to the power of minus ix is 1. And mod ey is ey only, because an exponential function is always non-negative values it will give. So therefore it is e power y for all z belongs to C. Yes, this function has the given property. Therefore, the function given in this option 1 satisfies the given property. Therefore, option 1 is true. Yes, we have arrived at the answer also. The answer to this question is option 1. As this is a question from part B wherein only one option is correct, and that option is option 1 is true. Therefore, the answer to this question is option 1. And that is the detailed discussion of this question. And practically the answer is over, and you need not check the other options. But however, our students insist on how the other options are not true. Yes, that we will show you now. We call on option 2. F of z is equal to c e power I z for some c belongs to a set of complex numbers with mod c less than or equal to 1. Take the modulus. Mod of f z is equal to mod of c e to the power of I z is equal to mod c into mod of e to the power of I into x plus iy, and mod c is given to be less than or equal to 1 is less than or equal to mod of e to the power of ix minus y, that is equal to mod of e to the power of ix into mod of e to the power of minus y, and mod of e to the power of ix is 1, and this comes out to be e to the power of minus y. Obviously, this function doesn't have the given property. In the given property, it is less than or equal to e power y for all y, but here it is given to be e to the power of minus y. We have proved this is less than or equal to e power minus y. Thus, mod of fz less than or equal to e power minus y for all y belongs to R. Clearly, this function fz doesn't satisfy the given property. Therefore, option 2 is not true. Let's now move on to the third option. F of z is equal to e to the power of minus ciz for some c belongs to C with mod c less than or equal to 1. Take the modulus, work out, and this comes out to be e to the power of cy, where c belongs to the set of complex numbers with mod c less than or equal to 1. Now, if f of z satisfies the given property, then e to the power of cy is equal to modulus of fz. If it satisfies the given property, it is less than or equal to e power y for all y belongs to R. Now, if you take c is equal to 0, mod c is less than or equal to 1, it satisfies. So, c is equal to 0 and y is equal to minus 1 you take, the left hand side becomes 1 and the right hand side becomes e power minus 1. So, this will give rise to 1 less than or equal to e power minus 1. This will give you e less than or equal to 1, which is a contradiction. This contradiction tells you fz doesn't satisfy the given property. Therefore, option 3 is not true. Right. Option 4. We do it in a similar manner as in option 3. F of z is equal to e to the power of ciz for some c belongs to C, a set of complex numbers with mod c less than or equal to 1. Take the modulus, simplify, you will get e to the power of minus cy, where c belongs to C with mod c less than or equal to 1. Now, do the same thing as in your earlier case, then you will get a contradiction, and that will tell you that fz does not satisfy the property, the given property. Right. So, arguing as in the option 3, we get that this function fz does not satisfy the property. And a similar argument, you have to make it there, right? You have to make it there, and one is getting a doubt. One is getting a doubt. Now, c is equal to 0. C is equal to 0. That will be 1 less than or equal to y is minus 1 e. So, are you getting? No. You have to put the other way around. The other way around. C is equal to 0. Y is equal to 1. C is equal to 0. So, 1 less than or equal to e power minus 1. Agreed, right? Y is 1 plus 1. So, C is 0, Y is plus 1. You substitute. You will get 1 less than or equal to e power minus 1. So, you get a contradiction. Thus, this shows you that does not satisfy the property. Arguing as in the option 3 doesn't mean the same argument, the same values, but a similar set of values for which you get a contradiction you have to do. So, thus the option 4 is not true. Thus, the answer to this question is option 1. That is the detailed discussion of the solution of this problem from the section complex analysis related to entire functions. It is definitely a very easy question. Right. I am sure that you have understood the solution of this problem. I thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. I wish you all the best. Thank you.